Gigabyte has sent KitGuru 2 motherboards. This is the Z790 Aorus Pro X and this is the Z790 Aorus Master X. The X means they are Z790 refresh motherboards and they are intended for pairing ideally with a brand new 14th gen processor. We have here the Core i9-14900K and here the Core i5-14600K. The thing is, KitGuru did not review those processors at launch, and there's a really good reason why. So let's kick off this look at these two motherboards by first talking about those CPUs.
Utilizing a 90-degree rotated motherboard layout, Alta F2 carries the torch of Silverstone's stack effect, bottom to top directional airflow design legacy.
When Intel recently launched their 14th gen series of desktop processors, we were sent the Core i5 and Core i9, which are in these motherboards, and we also got our hands on the Core i7. So we had the full set of processors. They're only launching the K and KF in the first instance. The rest of the SKUs will come early in the new year. The thing is, the specification of these 14th gen Raptor Lake refresh processors is amazingly similar to the 13th gen Raptor Lake, both in terms of core count and clock speed. It's the Core i7 that stands out. This processor has 4 more E-cores than the 13th gen Core i7, and that gives it something of an edge when it comes to multi-core benchmarking. For example, in Blender, you'll see the new Core i7 is better than the previous Core i7, but when it comes to Core i5 and Core i9, it's purely down to clock speed. In essence, 14th gen has 200 MHz over 13th gen, and it's very easy to make the argument that these are revised parts. So for example, they should be called Core i9-13950K and so on. And of course Intel has a history in this regard. We already have KS parts. The new K is essentially the existing KS. Not such a big deal. The funny thing is, this does actually help us in one regard, which is that the existing LGA 1700 socket continues for another generation. So it is launched with Alder Lake and Z690, and then with Raptor Lake we had Z790, and now we have Z790 for 14th gen. So the sockets had 3 generations, and these Z790X refresh motherboards from Gigabyte are down to the hardware of the motherboard and not down to the chipset. Intel's made a few tweaks to the software that runs around these processors in terms of how they boost when they're under load, and also there's an application called Application Optimizer, which at the moment only works with 2 games. So that's a bit of a sideshow as things stand. Clearly any software that works on 14th gen could work on 13th gen, but you know how it goes, sometimes you only get the new toys if you buy the new hardware. That preamble explains why KitGuru wasn't excited about the Intel 14th gen Raptor Lake refresh processors, but it does not explain why we didn't review them a few weeks ago at launch. The answer to that question is really straightforward. It was entirely predictable that when we compared 14th gen with 13th gen, we would be entirely underwhelmed. And we saw exactly this when the reviews went live.
So overall, I'm a bit disappointed in the 14900K. It is just not the upgrade that it should have been.
Okay, so there you have it. The Raptor Lake refresh is pretty much just that, and it certainly doesn't deserve to be called a 14th generation. Sorry, I mean generation.
So wrapping up the 14900K review then, we're just disappointed. I mean, it's not, there's very little change in stock performance. This isn't deserving of a new number.
The problem here is that 14th gen is not bad, it just doesn't compare well to 13th gen. As I say, it's not really a new range of processors, it's a revised range of processors. So if you currently own 13th gen or possibly even 12th gen, I wouldn't suggest for a second you should consider upgrading to 14th gen. Z690 to Z790 is a really small step. On the other hand, if you have a PC that's 3, 4, 5 years old, you might be thinking about building a new PC, in which case why wouldn't you consider 14th gen rather than 13th gen? And that is why we're going to take a look at these Gigabyte motherboards and also how they handle these 14th gen processors. We're going to take a quick look at the Z790 Aorus Master X before we dive rather more deeply into this Z790 Aorus Pro X, and my thinking here is fairly superficial. The Pro X is cheaper and it's white, and that's quite rare in ATX motherboards. However, the Master X has a lot to say for itself. It's an expensive motherboard priced between £550 and £600 here in the UK. It's eATX and it's fully loaded with features. In the package you get relatively few accessories. You've got an antenna for the Wi-Fi, 2 SATA cables and a couple of temp sensors, and also one of those handy little gadgets that you can use to connect up the front panel headers to your case and then plug the block directly to the motherboard in one go, rather than fiddling the little wires into place. That's it. It's all about the motherboard. The first point to note is that the SSD covers are tool-free. You will note I've been testing. I have a Sabrent Rocket Plus SSD already installed, and this cover, and away it comes, revealing 4 more M.2 slots. Clearly the layout is about the primary graphics slot and a whole load of M.2s, but you do have 2 expansion slots down bottom. At the top of the board, hidden in the corner, as we can see, we have a pair of EPS connectors. On the side we have the main power connector. Across the top we have a few fan headers, LCD postcode debug display, USB-C, 2 USB 3.2s, quick release for the graphics card, laid down SATA connectors, more fan headers, and across the foot of the board USB 2 and even more fan headers. Essentially a fully loaded board. We have a backplate, and we also have a few features that are not immediately apparent to the eye. First we have the heatsink on the primary M.2 slot, which is absolutely enormous. So enormous in fact it has a name. Next we turn to the cover over the VRMs, and we can see the rear I/O shield has a series of airflow holes. That's just to help keep the VRMs under control. The VRM heatsink itself, as I previously mentioned, is absolutely enormous. And when we look at the expansion slots, both for the graphics card, the 2-layer PCI Express and the memory, we can see they are metal reinforced to give maximum support to your hardware. The same is true of the M.2 slots. Less obviously, this motherboard uses an 8-layer PCB for extra durability and for signal integrity. Memory support, as with all the Z790X refresh motherboards from Gigabyte, goes up to DDR5 8266. When it comes to connectivity, we have 10 gigabit Ethernet. For wireless, we have Wi-Fi 7, and the antenna is described as a high gain antenna to ensure maximum speed. The VRMs on this motherboard are a 20 plus 1 plus 2 configuration, 20 by 105 amps plus 1 105 and 2 times 60 amps. Let's see how the Z790 Aorus Master X treats the Core i9-14900K. We have a Kraken X63 cooler from NZXT, which is a 280mm AIO. I've installed a pair of Noctua fans on it, so I have complete control over PWM without using NZXT CAM software. We have a Seasonic PX1600 power supply running the show. The memory is the same G.Skill DDR5 6000 Expo I've used for my recent AMD testing. SSD, as you saw earlier, is a Sabrent Rocket Plus 1TB, and then the graphics card, Gigabyte GeForce RTX 4080 Gaming OC. As you can see from HW Info, the BIOS has set the boost power of the processor to 4095 watts, which is infinite, and then it pulls back to 280 watts. So let's start Cinebench 23 and see how the processor actually behaves when it's working for its living. Initial boost at full power up to 5.7 GHz on the P cores, and then as the power pulls back to 280 watts, which was the limit because it reached 100 degrees very quickly, we saw the speed drop to 5.4 or 5.5 GHz depending on where we are in the Cinebench cycle. And let's see what the final score is. 38,646, which is slightly lower than I saw recently for the Core i9-13900K. And I would say the reason is because the BIOS is essentially brutalizing the processor with more power than it requires. The thing is that we found exactly that when I first reviewed the 13th gen processors, and the answer was to undervolt the CPU. This is no mystery. The surprise to me is that Gigabyte has released a revised motherboard and essentially has repeated the sin that we saw about a year ago. Anyway, the Core i9-14900K is essentially a Core i9-13900K. Moving on from the approximately £600 Master X motherboard, we're going to move to the significantly cheaper £420 Pro X. This is ATX rather than eATX, but it shares a number of features with the Master X. However, there are also some significant differences. So for one thing, it's ATX in form factor, much more convenient when you're doing a PC build because most cases support ATX, some support eATX. Also, white in colour. You may have noticed in recent case reviews I've used both of these motherboards, primarily because I wanted to use the latest processors, but also because there are times when a white motherboard really pops in a build as opposed to the usual black, or in this case, black, grey and blue. The Pro X is an 8-layer PCB, supports up to DDR5-8266, and it has quick release covers on the M.2, so the top M.2 is Gen 5. And then we have 4 more M.2s, which are Gen 4, 1, 2, 3, and then the 4th goes on top of the Wi-Fi 7 card. On the I/O we have plenty of USB, we have the antenna connection points for the Wi-Fi 7, the Ethernet is 5 gigabit where the Master X was 10 gigabit. However, 5 gigabit is plenty fast enough. We have a substantial heatsink on the VRMs, it's an 18 plus 1 plus 2 configuration, 18 times 90, the other 360 amps. So while you might think this motherboard is all about the aesthetics, quite clearly the hardware is substantial. Moving around the board, at the top we have 2 EPS connectors, various fan headers, main power, the usual USB for front panel connection, various fan headers. This is interesting. This USB-C is called Sensor Panel Link. Gigabyte has included this connector on 2 of its refresh boards, funnily enough the 2 that are white in colour, and the idea is it's so you can connect a secondary display inside your case. We saw something similar with a Corsair liquid cooler I looked at relatively recently. The idea there apparently was that the connection point was for an LCD that's going to go on the pump body. But whether the display is on the cooler or near the cooler, the principle is the same. I think we can expect to see more of these USB-C connectors during 2024, and hopefully we're going to see cases that have an LCD as part of the design rather than an addition you have to plug in yourself. Moving down the board, laid down SATA, front panel headers, loads of connection points for USB and also for fan headers. It's white in colour, it's ATX, it's reasonably cheap, and it's loaded with hardware. But let's see how it performs with this Core i9-14900K. The Pro X is running exactly the same hardware as with the Master X you saw a few moments ago, but before we do a quick run of Cinebench, let's first take a look at some B-roll of the BIOS settings. This has got a Core i5-14600K installed, but it doesn't make much odds. The point here is to show you the aesthetic of the BIOS. It's nice and clean, and we have a white background which matches the motherboard. Yes, I know that's not the most technical description of a BIOS I've ever given you. However, if you're buying a motherboard primarily for its looks, why not go the whole hog and have the same look on the BIOS setup screen? Okay, let's do a quick run with this Core i9-14900K in Cinebench R23 and see how the Pro X delivers. And the final score comes in at 39,127, which is just a rounding error away from the score we saw previously. And the explanation is the behaviour of the two motherboards is absolutely identical. Initially the processor surges to 360 or 370 watts, 5.7 gigahertz all cores, then it pulls back to 280 watts, 5.4 to 5.5 gigahertz on all cores. That's decent performance, but the V core's just too high, and the consequence is the power's too high, the processor gets hot, and you don't get all the performance that you might get. That is of course just a brief overview of the behaviour of these two motherboards on one processor in one test. So let's dig in a little bit deeper to the performance of 13th and 14th gen Intel processors on this Pro X motherboard. Before we dive into the charts for my not a review of 14th gen processors, but kind of, let me tell you what I've done. So I've benchmarked the i5, i7, i9, 13th gen and 14th gen processors on this Z790 Pro X motherboard. I used this memory rather than the memory you've seen so far. So this is the Trident Z5 Neo from G.Skill rated at 6000, the same memory that I used when I did the AMD 3D processor some months ago. And the reason I used 6000 at the time for both Intel and AMD was a level platform, because at that point AMD only supported up to 6000 mega transfer memory. They now have pushed further. And one of the big deals with these motherboards is they got to 8266 DDR5. Not that I've ever seen such a kit. So memory speed is clearly a big deal. So I've gone for this G.Skill Trident Z5 RGB rated at 6800. So I've tested these 6 processors with this 6800 mega transfer memory. However, the figures I've used from previous reviews are all with the 6000 memory. In the charts, I will be categorically clear when I've used old figures and when I've used new. This is primarily so we can just see how 14th gen compares to 13th gen. It's not to say whether or not Intel has taken the gaming title from AMD or not. Not the point at all. Z790 refresh and a quick look at 14th gen. So here we go. In Cinebench R23, the Core i9-14900K comes at the top of the chart, beating the Core i9-13900K by a very few points. Essentially, it's a tie. Then we have the two 16-core Ryzen 9s, the new Core i7, the 13th gen Core i7, and then the Core i5's 14th gen ahead of 13th gen, followed by the 3 Ryzen 7s. When we look more closely at the Cinebench R23 scores and we just look at the Intel figures, what we see is actually at the top of the list we have the Core i9 from its original review on the MSI MPG Z790 Carbon Wi-Fi, scoring 39,202 points. That puts it slightly ahead of the Core i9-14900K and Core i9-13900K tested on the Aorus Pro X. And the particularly interesting thing here is the i9-13900K on the MSI at the top of the chart was running on 260 watts, where the i9-14900K is on 280 watts, and the i9-13900K on the Gigabyte Aorus Pro X in third place, 304 watts. The less power you use to run the processor, the more effective the processor becomes. If your motherboard BIOS isn't doing a decent job, for goodness sake, undervolt your Core i9 processor. Cinebench R23 single core. This is a clear win for the i9-14900K on the Pro X, as it runs at 6 GHz and that gives it a score of 2292, which is a clear victory over the i7-14700K at 5.8 GHz. Blender 3 Classroom. This is pretty much a test of pure grunt, and the two Ryzen 9s with 16 big cores and no little cores win. These are old figures that were taken from my previous review, but they won't have changed and we stand by them. In third place we have the new i9-14900K, but realistically it's in a dead heat with the i9-13900K. Move down to 5th place and look at the Core i7-14700K, which has a clear advantage over the Core i7-13700K thanks to its extra E-cores and clock speed. 7-zip benchmark. The two Ryzen 9s at the top of the chart, followed by the Core i9-14900K, and a short distance behind that, the Core i9-13900K. Ada64 memory benchmark. To spell it out again, I've retested the Intel processors with DDR5 6800, and not surprisingly, those processors are at the top of the chart. I've left in a Core i9-13900K with DDR5 6000 figure just for the interest, and we can see that that does perfectly well, but is beaten by the 6800, which is no surprise whatsoever. And behind that we have the various AMD processors running on DDR5 6000. At the very bottom of the chart, a long way behind, is a Ryzen 7 running on DDR4. And then we move on to some gaming benchmarks, starting with Borderlands 3 at 1440p. Now we're mixing old and new figures here, so anything apart from Intel is just for indication. So when I say that at the top of the chart we have the Core i9-14900K, it is entirely possible that if we retested the Ryzen 7 7800X 3D, it would gain more than 1 FPS. However, just look at the 1% low for the Intel, 144 FPS is absolutely mighty. Down in 4th and 5th places we have the Core i7-14700K in a dead heat with the Core i9-13900K. Borderlands 3 at 1080p, at the top of the chart we have AMD 3D processors. In 3rd place and quite a distance behind we have the Core i9-14900K. Again, it is entirely possible those two AMD processors at the top of the chart would score even better if I retested them. In 4th place we have the Core i7-14700K, and it is only a very short distance behind its much more expensive i9-14900K. Marvel's Guardians of the Galaxy at 1440p. Top of the chart, the Core i9-14900K. 2nd place, the Zen 4 Ryzen 7 3D. Again, if I was to retest it, it might improve. And behind that we have the i7-14700K. Marvel's Guardians of the Galaxy at 1080p. Top of the chart, the Core i9-14900K, a surprising distance ahead of the Core i9-13900K, which is also beaten by the Core i7-14700K. 14th gen, for some reason, is working very effectively in this game. Let's fall back on an oldie but a goodie. Shadow of the Tomb Raider at 1440p. Top of the chart belongs to AMD 3D processors. In 4th place we have the new Core i9, which is a comfortable distance ahead of the new Core i7. Shadow of the Tomb Raider at 1080p. Top of the chart again, AMD. 3rd place, by a reasonable margin, the Core i9-14900K. Interesting to see the Core i7-14700K again doing well. Far Cry 6 at 1440p. Top of the chart it's AMD. A very short distance behind we have the new Core i9-14900K. And then we have the Core i7. After that the scores start to spread out quite a bit. And finally we have Far Cry 6 at 1080p. At the top of the chart the Core i9-14900K. Once again in 2nd place the Ryzen 7 7800X 3D. Only 2 FPS. Were we to retest, I don't doubt it will make that up. However, the 1% low definitely works in favour of Intel. And that brings us to the end of this quick showcase of the Gigabyte Z790X refresh range, exemplified by these two models, the Z790 Aorus Master X and the Z790 Aorus Pro X. There are of course other models in the range, both cheaper and more expensive. But there are a number of common features across the range, including loads of USB, 8-layer PCB, support for DDR5 8266, and the connectivity is Wi-Fi 7 across the piece. Looking at these motherboards has also given us the opportunity for a quick rundown of Intel's new Core i5, Core i7 and Core i9, or as we prefer to say, revised Core i5, Core i7 and Core i9. This means the LGA 1700 platform has a life of 3 years rather than 2, and let's face it, that has to be a good thing for PC builders. That's the end of this roundup, and it so happens my next job is a PC build, and I have to use a motherboard, and it's definitely going to be one of these two, but I'm not quite sure which one it will be.